Thank you for coming. I'm PIotr Spikowski, and I work at Volvo Group IT. And today I have a pleasure to talk about sins of .NET developers, but specifically about sins which can be classified as deadly sins. We will see what we mean by that. I work for the Volvo Group IT, and I work within a department which is called DRS. As it may not tell you anything if you are out of the Volvo, it's some kind of the R&D department when we specify how to build apps, which technologies should be used in which cases. And then among other things, we are also doing code and architecture reviews. So we have a chance to take a look at source code of many applications, not only those built within Volvo. If we, for example, buy something from the market and we do it together with the source code, then we must also do a review of such app often to take a look at the quality of the implementation and try to, for example, predict the future costs of the maintenance. The agenda for today, a short introduction. I would like to really point out why do we try to talk about deadly sins of .NET developers. I must admit it's not the first time we are talking about it, and we always say, all right, this is the last time. We will no longer talk about sins of .NET developers, but then after a while we open another project and we, oh my God. And we just realize, you know what, we can still discuss multiple sins, we can add more sins. People learn on their own mistakes, but they start to do new mistakes as new technologies arrive, etc. So you may update that presentation year by year. And for today, we have selected a few areas. The first one is performance. The second one is security. We will try to, I'm afraid, also talk about some knowledge behind it, give you some background for each of them. Then we will take a look at some simplified code examples for each of the areas. And as our time is limited, then I will try to discuss other things. But this time shooting like a machine gun, I'm afraid. Because, as you may suspect, it's a quite large topic when it comes to various sins of developers. So let's begin. Let's start with a short introduction. But before we do that, a small disclaimer. What we gonna present, it's not a real source code coming from real applications. It's not that we have something to hide. It's not like that. It is more that we wanted to present a simplified version of this code just to, as we say here, convey the message. So we will not browse through the large solution just to find one problem on one issue. We would rather present a small code snippet and focus on that just to give some example and just to prove that we may still have sins when it comes to the implementation. This is quite obvious. It might be that everyone knows about those things. If you no longer do those things, then I would say it's good for you. It means you work in an extremely mature organization. You have extremely good control over the quality of your implementation. And what we are going to present, those might be common sins, but it does not mean they are the most harmful. It all depends on your type of the project, type of the implementation, and we just want to change a way in which you think about your code, about the work which you do, rather than trying to really present every single mistake which can be made in the code, simply because it's not possible. So what we try to present is let you learn from common mistakes. And as an introduction for a while, imagine that we as developers are right now not building software, but instead of that, as I'm coming from Volvo, and instead of that, let's assume that we build trucks. And as usual, our customers would have some form of expectations, and probably they will have something like that in their heads. So we build requirements. One customer may say, I want a green truck, which is electric or fully hybrid. The other one may say, I want a standard truck to be able to carry high loads. Then, as developers, but this time building trucks, we sit together. We, of course, need to finally construct, meaning implement something. But what if we end up with something like this? Remember the picture from the start and what our customer had in their heads when it comes to the requirements. But how often the end result is closer to that picture presented here? And even worse, how often, if you take a look at the internals of the implementation, then it's something like on that picture on the right. It's a spaghetti code, copy-paste coding, and all the worst things in the world which you can imagine. So, if you don't believe, then we can still look at some comments coming from the source code of some of the applications. For example, someone was counting total number of hours wasted in the code file. Yeah, it might be interesting, but why not trying to correct or improve the code instead of that? Throwing some exceptions, not saying anything, introducing some strange constants which should not change over time, and we may go on and go on. A classical example, magic, do not touch. How often you are afraid to change a code within an application because you do not have unit tests, you do not have regression tests, you do not know what's the influence on the entire implementation. Finally should never happen. Code should never reach finally. That's quite interesting. And if you don't believe me that it's still an issue, then you can, of course, go, for example, to the Stack Overflow and look for more. And because we still find such things, our session goal is to end with a product which is somehow similar to this. And as I said at the beginning, the main idea is to, during that session, increase your awareness and not really try to present every single possible mistake which can be made in the source code. So let's start with first selected area, performance. And if we keep still the analogy to the truck business, at the top you may see a nice speedometer. And if we compare it to software, then probably it should show how fast our app is. I'm afraid it's not implemented in C#, it's rather in a native implementation. But if you have a C# code, the question would be really if you are able to say how fast your implementation is. On the right-hand side, you can see an Iron Knight truck, if you still compare to trucks. The truck holds the world record. It's the fastest truck in the world. Extremely fast gearbox, strong brakes, 2,400 horsepower engine. But if you compare to C# code, C# implementation, can you say really that your code is, or your implementation can be compared to that truck, or maybe to something which we have seen before, like the old one, which has been or was produced in Poland some time ago? So even more, what happens if you change your implementation? Can you predict the influence? Will your app run faster? Or maybe will run slower? Can you really even say that? And then we come to some theory before we go into some of the examples going from the code. theory about what are the common sins and how we see those sins. First of all, we often have a tendency to skip performance when we define our requirements. So we often say and collect standard requirements, but we do not even think about performance. We often forget about specifying real data volumes, or we don't even know what are the real expected data volumes. How often you create a view, you have a list of orders, you deploy the app, and after 1 year or 2, the app is slowing down and working slower and slower. What can be the reason? Why not predicting that before that happens? The other aspect is that even if we think about performance, we must measure it. We cannot really talk about performance. Performance is not related to any feelings, or I should not suspect wherever something is fast or slow. I must really specify what does it mean to be fast or slow. So I must measure things and compare those to the figures in my requirements. The other common sin is optimizations without figures. It's in relation to the previous one. Because we as developers, we love coding, of course. We have a tendency to improve our things, our implementation. But imagine two devs speaking to each other in the kitchen, somewhere in your company, and one is saying, well, I have improved my implementation. But is this really improved? Where is the proof then? Do we measure if it's faster or slower? How often we try to optimize in not needed areas? What I mean by that is that it should not be up to the developer to decide where to optimize. We are creating apps for some business purpose. And we should, for example, optimize area within our app which is responsible for core business process. If you are following DDD, probably it's going to be in the core domain. We should not try to improve some subdomains or something like that if it doesn't matter so much for the business. And we said that we should measure things because this is our base. Even if we have requirements and all the other items fulfilled, we must have measures in order to be able to improve. And as long as unit or integration tests are good for their purpose, they are not often the best candidates to perform any benchmarks. We as devs, we often try to measure application on our own, adding some counters, adding some timers, etc. The common mistake is that we are by ourselves. The measuring code is measuring itself. So what I'm trying to say is that it's not that easy to even correctly measure things. We may, for example, include just-in-time compilation in the measurement. We may include some cache warm-ups if you have some statics which are initialized once at the application startup or at some specific point. But those should probably be excluded from the measurements. We have a tendency to exclude hardware configuration, meaning that two devs still talking to each other, and one is saying, this is running quite fast, but the other is saying, no, that's extremely slow. But do they really compare on the same hardware? One might be running on laptop and the other one might be taking figures from a server. So ensure that you have a stable environment used to really compare things. And the same is for a runtime environment. We may have a target .NET standard those days, but would it be the same to run an app on Windows as on Linux? We may have some performance differences. Would it be the same to run .NET Core app on Windows and .NET Core app on Linux? It might not be the same, so we must ensure that we compare the same things. So enough about this introduction. Let's take a look at some examples then, coming from some applications. As I said, we were trying to simplify those examples just to convince you that we should constantly try to improve ourselves, even if we are within the .NET environment. The first example is talking about that even if we have garbage collector, which is doing hard work for us, we have a tendency to forget about memory management at all. Here someone was trying to process messages, and then someone was trying to, based on some part of the message, decide what should be done. It might be absolutely fine to have such code, but what if you run it millions and millions of times, as it was in that case? As we know, substring in .NET will in fact allocate memory and do a copy each time you call a substring. So you will have multiple allocations happening, and as the result you may at some point receive unnecessary pauses done by the GC. So the change was to really, someone has realized that, right, but we can read the message as a byte array. We can just read the first part as an integer, as a number. We don't have to read it as string. And then the change was simply to just read the first part as integer and just compare integers. So even if we take a look at that simple example, of course, this could be improved in another way, but then you would have to compare which one is better. But the main message to you is that do not forget about memory allocations and all those stuff, even if it seems like garbage collector is, for example, doing the hard work for us. So do always try to investigate deeply what you have in the implementation. And here comes another example. At first glance, it looks quite easy. Probably someone had a requirement to log something, so we couldn't skip logging of that thing. And then string format was used to put a message and pass the request ID, so we could say if the request of some number has been placed. Quite easy. But again, what if you really executed millions and millions of times and you really want to improve every single line of your implementation? Then the problem is here. String format takes a string as a format and takes an object as an argument. Request ID is a structure, is a value type. Every time you pass a request ID, which is a value type, and you pass it to argument of type object, then a boxing will occur. And boxing is horrible from the performance perspective. So in fact, the correction here was quite easy. We have just replaced and added explicit call to the method toString. And what is interesting to clarify, the first version would be absolutely fine if you run, I would say, a code in a standard way. You do not care so much about performance. But if you are fighting for every single millisecond, imagine IoT, you receive millions of messages. You really want to improve every single line of code. Then the second version is better than the first one. And what is more, if you use tools or static analysis tools, for example, ReSharper, then I must admit ReSharper will say that you do not have to call toString in the second version, just remove it. So the other thing is that do not fully trust in the tools which we are using. They are suggesting things which are good in most of the cases, but not in all of the cases. And this is similar if we use a new structure, string interpolation. So we have a $sign at the beginning, but that is translated with an updated compiler into the simple string format. So in fact, we have exactly the same issue. So even if we base on that simple example. The message from me to you is that even if something seems to be extremely simple, do think about it twice if you try to improve performance of your app. Another example. Someone had some dictionary of nodes where key was a string and a value was some form of a node. And someone was just trying to find current node, trying to check wherever there is something added, returning a value or returning null if there is no value. But we must really know what's the API given by the framework. And the simple change from contains to try get value, as I recall, has improved the overall performance by 5%. And of course, one more time, the first version, it's of course working, but remember, we are fighting for every single millisecond, because if we correct multiple places like those, then in the end we will receive a huge benefit from the performance in our application. Another example, when we have a tendency not to think about internals. We have a list of items, and someone was checking wherever processing is needed, just checking wherever we have any items on the list. And we love Linku. It looks great in code. So someone has used any method in order to check if we have any items. But do we really know what's behind that call from the performance perspective? First of all, if you look in the source code of the .NET, which is right now open sourced, which is great if you try to really improve even performance of your app, you will notice that any will, the first thing which is done, any calls the get enumerator. Meaning that it will call get enumerator on the list, because our items, it's just a list. Then get enumerator on a list allocates a new list of t enumerator. So we have a question mark in our head right now. There is some form of an allocation. List t enumerator is a struct, so we should not have any issues here. But if you further look at the usage, you will notice that it's a struct, but then it is casted to an interface. And again, if there is a struct in .NET implementing some interface, and you use an interface, then the boxing will occur. Furthermore, in fact, it's a value type which will be copied. So even if we simply call items any, we will have an allocation and we will have a boxing operation. And again, the same story. This may rise to issues when it comes to improvement of performance of an app where we are fighting for every single millisecond. And as simple as that, after an investigation, someone has replaced the call to any with items.count greater than 0. And I know that it looks simple, the correction here looks simple, but believe me that you need multiple hours often to find an issue and to find a place in which you can improve. You need to analyze memory, check allocations, etc., etc. So, looks simple, but the message to you is that, one more time, look at every single line of code, and do not even believe in what is used by default. Just check everything. And it was a bit on a low level, but the question might be if it's all the time that level low. Of course not. We have a classic example here that someone was creating some query, defining it this time using an Hibernate mapper. We may have similar issues using entity framework. but the problem was that the developer was not thinking about what's really executed on the DB level. So it's a classical example, and it's just showing that it's not always about that low-level optimizations. You of course start with more obvious things like that one here. And every time you create something like that, do not trust in tools one more time. Do not trust and hibernate fully. Do not trust entity framework fully. Do not believe that if you construct a query, you are happy in the end that it's working. You do not have to touch or write raw T-SQL, but it might be not the best version. Still, think also about performance from the design perspective. A classical example that we have an order, it's probably an order aggregate, which has order lines, and each order line has a part. Then someone had a business requirement that it should be possible to search some orders with a specific price range. And if we stay with the version at the top, then you need to take order lines and take parts in order to determine what's the price for the complete order. But maybe it's better to just introduce a field on the order level called total price. So what's the message here? The message here is think all the time about performance also on the design level. And another example of this, we love microservices, we love REST, we love all those things, but if we have, for example, a mobile client calling REST services, is it always optimal that it's calling RESTful services directly? The question may be, what's the network between the client and the backend, or multiple backends? Maybe it's just good to introduce an API gateway here. And of course, the API gateway in the microservices world is also used for another purpose, but here we are looking at that from the performance perspective. So what's the cure without any surprises? Include performance in performance, design, measure things, ensure that what's measured is comparable, so ensure that you measure on the same environment, on the same or similar hardware, you are using the same runtimes, etc. And if you really measure something, act. Because how often we measure things, we see that the performance of the implementation is going down, but no one is taking any actions and taking any decisions in order to improve. Because if you leave it for a while, then you will have more and more problems in multiple areas, and it's going to be harder and harder to correct. And of course, we have some tools, frameworks supporting us, some open source frameworks, so for example, benchmark.net, which you can simply create a console app, mark some of the methods with a benchmark attribute, and just tell the benchmark.net, do please measure things for me in the simplest form. And it will try to do it in the optimal way, so you do not have to care about starting some timers, fix, etc. to correctly measure your implementation. Of course, Visual Studio is also supporting us, but important thing here is that really do code reviews within your teams. Do not try to skip them, and change your mindset, change a way in which you think about your implementation. Do include performance in architecture, design meetings, etc. So it's more about changing a way in which you think about things and a way in which you work with your implementation, your software. And another area which we have selected for today, security. And just as the starter, some horrible figures collected by quite big companies like Symantec, showing that, in fact, 75% of attacks occur on web apps. Probably you most likely create web apps. And what is more terrifying, that 95% of web applications have security-related weaknesses. So if you right now think if you have any weakness, then the answer is probably yes. The question is, what's the influence on the app and on the business and on the assets which you are trying to protect? Even more, 75% of mobile applications fail basic security tests. This is from 2015, but I have an impression that nothing has changed here, because we still have a tendency to forget and not to think about security as we should from the start. And in a similar way, security should still be part of your requirements. So even if we take the simplest thing like authorization, authorization should be part of your business requirements. Authorization is related with your domain and should be, if you follow DDD, somewhere within your bounded context. You should classify data. So if you have some aggregates, roots, entities, you process some information. You should discuss with your customer, should I protect that aggregate, that entity, that information which is represented by that entity or not? Because it's only the business who is able to specify what should be protected. So for example, you can classify data as open and internal for the starter and focus on things which are internal and take a look at the complete flow of entities aggregates. Do I expose that thing to the UI? Do I only process it internally or not? And then apply correct things to make the complete solution more secure. And do test, of course, your things. So even if we come back to the simplest example with authorization, then we should, of course, test authorization as we do test any other business logic within your applications. Do be careful when taking any assumptions. So one may say, I do not have to encrypt anything because it's stored in the configuration file on the server. It's a correctly wrong assumption. Or someone may say, I do not need to protect that because I'm creating a native mobile client. The implementation is native, so I don't care. It's another example of correctly wrong assignment. Everything what's on the client is treated as being insecure. And what's more, update tools, frameworks, and revise algorithms which you are using. So if there is some security vulnerability, it's probably corrected in an updated version of the framework tool which you are using. So try to be really up to date. And a few other examples, more related to developers. We may hear two devs talking to each other that I don't care about security, I have set anonymous, it's just an internal app. But frankly speaking, the first thing which the hacker would do will try to really reach your intranet and do the attack from the intranet, not from the internet. So do not try to assume some things. Do always protect. And it's exactly the same for now. For the anonymous works rules, that two devs meet each other and solve a problem with authentication, just removing the authentication fully. Do focus on authorization. So a classical example. You protect assets which are on the server. You protect your business logic. So probably in most of the cases, authorization should be on the server side. Then, in order to improve usability, you may add it into the client, but not the other way around. And of course, if you classify data and you push something to the client which is treated by business as confidential, then do ensure that you protect those assets on the client side. Do encrypt them on the client side. Do correctly protect client-side databases, caches if you have any. So do not forget about such things. And a classical example which I have just specified, passwords in clear text on a backend server. It's totally wrong. And a famous dev to products where developers, we create fully secure solution, we test it, etc., and so on and so on, and in the end we just give developers direct access to the production environment. And they just run multiple T-SQL scripts directly because they need to solve something. I don't have to tell you about the consequences. So, some example. The first question, and the question which we often hear is really security simple? We will take a look at the classic example. This time, someone had some knowledge about security, and that person knew that I cannot store passwords, user passwords, in clear text in the database, but instead of that, I will store a hash of a password. It looks fine from the beginning, but is this implementation really correct? Not fully, really. Someone was just taking a string representing the password and was using SHA-256 in order to compute a hash. The problem with that implementation is that the same password will all the time create the same hash value. So for sure that implementation is not fully secure. The other attempt to do this was, all right, so we need to add a salt value, that's what is called. We need to add a random value into the password and then compute a hash. And this random value can be stored together with a password in the database, close to that password. You do not have to protect this value. It's only used to ensure that every single password, and even if we have two the same passwords, we will have two different hashes, not the same values. And then in the first implementation, so someone was using the random type in order to create a random value. But I'm afraid still that was incorrect. Random should not be used in any operations which should be secure from the security perspective. What should in fact be used is just the RNG crypto service provider in order to generate random numbers in the correct way. So you see where it goes. We thought at the beginning that we are going in the right direction, that we are improving our application, increasing security, but this was not true. It took us some time to investigate what we were doing wrong. The question would be, of course, what should be the length of this random value? The other question might be, I keep password in a string. Remember that we have a type in .NET which is called secure string. And in fact, all such values should be put in and represented by a type secure string. You should never use string in order to keep passwords in memory. So there are many, many things about which you have to remember if you talk and consider security of your solution. Maybe you should not only introduce a salt value, maybe you should introduce another random value called pepper. This time that value should, for example, be stored in your front end in the configuration file, so it's not stored together on the same machine as your database is. So there are many, many things to consider. So the message and the output to you is that care about security, but do not try to reinvent the wheel. Do not try to introduce your custom solutions when it comes to security, because it's not that simple as it seems to be at the beginning, I'm afraid. And as you may suspect, the cure would be, of course, one more time, define security requirements. Classify your entities data which is processed by your system. Scan your apps. There are multiple tools allowing you to scan your apps. Those days, we no longer or not so often find classic security issues like cross-site scripting, etc., etc. It's also because ASP.NET is well secured and the default configuration is quite good. So you need to really do something in order to destroy it. But there are tools which should still be used. So, for example, given by huge companies like HP or IBM, which are able to take your app and scan your app, look for cross-site scripting issues and all the basic stuff automatically, so you do not have to do it manually. Define identity management rules. So what should happen if you add or remove users from the company? Will you also remove access to particular applications to that person? And analyze the risk. Do not reinvent the wheel, test everything Treat authorization as part of your standard business logic. Authorization should be somewhere within your bounded context. Prefer what is on the market. Claim-based authorization. Use standards like OpenID Connect, OAuth2. If you were using Google or Facebook to authenticate somewhere, using your Google or Facebook account, then you were probably using OAuth2 or OpenID Connect. This is just a widely adopted protocol to do authentication. Do not try to invent your own authentication mechanism. Just consume tokens created by the OAuth2 authorization servers. And as I said, there are many tools available. There is an organization called OWASP. OWASP is constantly updating its list of security vulnerabilities, and it's also providing free tools allowing you to take your app, scan the app, scan all the dependencies which are used by the app. So it may, for example, say, no, do not use this NuGet package, because that NuGet package in their particular version, then if you use it, you will have a security hole. Just do update or downgrade depending on what's the issue. So there are tools which can be used and should be used. You may, for example, attach it to your automated build process and scan the app automatically. Of course, nothing will replace a good person knowing security in depth, but at least it's going to be the point to really start with. And of course, as I said, we've just presented two areas and just selected simplified examples just to convey the message, just to tell you that and really convince you that it's worth to invest in quality in multiple areas, just to convince you that do not really try to skip any code reviews. I know that devs love coding, but they often do not want to show their results to other devs. Don't know why. We can learn from each other. Do involve, if you are a large organization, do involve security experts. Do not try to do all the things on your own. There are people which know security better than other areas, and they should do deep security investigations and scanning of your applications. And of course, those are not all the items. We could just go on and go on. We can find applications that do not test anything, do not have any unit tests, integration tests. We can find applications, yeah, that's just an example to missing tests. We don't want to assert true. So even if we have tests, we must ensure that tests, for example, are testing anything. And we may find more and more areas, but as I said, do code reviews, do design meetings. Control your quality, do ensure that you follow and respect solid rules. In the end, I would like to mention two other things, and to add a tendency that we have those days, blind love to fancy things. We love to start using new things only if they appear. I just give here an example of microservices, but still the question is, if you should always go for microservices, if you really understand it, what are microservices good for, what are overused, when they are overused. Remember, for example, that you may use Docker and Docker-related tools just to build images for classic standard monoliths. Using microservices does not mean using Docker. Using Docker does not mean that we have microservices. You may have microservices with help of Microsoft Service Fabric. There's no Docker at all by default involved there. They have just added a possibility to use Docker images. But it's just an architectural style, which we must understand and then follow it, not first follow it and then understand. So be careful with all those new fancy things. They are good for their purpose, but we must really remember about all the tiny details. communication between microservices, etc. And similar example is with REST. But if you think what's in your organization, we often say, well, I'm using REST. I have REST. But is this really true? Maybe I just only have the web API in use. Exposing an API to the client is not REST. It might be REST if you respect all the rules of the REST. But how many people expose links in the responses? How many people use correctly media types when it comes to the REST? So it's nothing wrong that we are not fully RESTful, but I must admit that I've seen only a few examples about real RESTful solution. So be careful with all those new things, which are catchy words. The question would be when to use REST. If I communicate between microservices, should I go for REST-based HTTP communication? Maybe I should use gRPC or something like that, or any other binary-based protocol. So just to underline that we have other levels of issues and that we must try to still extend our knowledge and be careful with what we are doing. Do really utilize your complete team, because it might be that one person is good in that area, the other is in another area. Do work on awareness, use proper tools, and do really ensure that your organization is more and more mature. This is all what I wanted to present. I hope that you found here something for you. I know that the examples was quite simplified, but my main hope is that I have somehow sent you the message that we need to really, one more time in our heads, rethink a bit a way in which we work.